god, it's so pretty. Okay, so I just noticed there's one game
Guys need to see about this.
No.
I know it. Noticed it.
Yeah.
Do you want more fire or less fire?
More.
Do you give the option? Do you give the option? Never give the option.
Okay, that'll be good. That's not such a fire. Okay, so. That's actually pretty good. You've probably seen this one before. It's relatively simple. Who's seen this one before? Okay, so I have a metal ball and I have a metal hoop. And if you look, I can put the metal ball into the metal hoop. Oh, okay, I know. That's pretty simple, yeah? So what I'm going to do is I'm going to heat up this metal ball. So what do you think is going to happen to this metal ball?
It's going to turn red.
It's going to turn red. Okay, it might turn red. I don't know if this brass one will turn red that much, but is it turning red? No. Is that just fire? It's starting to smoke. So what's going to happen when I try to put it through the metal hoop?
It won't fit.
It's turned black.
It's too big.
So it won't fit, okay? Because, remember, when you put more energy into these particles, what do?
Move.
So they expand.
They move faster. And as they move faster, what happens to them?
They expand.
They expand because they need more space. Remember I told you about the little kids when they run faster, they actually need more space? Same thing. When I heat this up, it needs more space. Okay, so as it takes up more space, it's not going to fit.
So it's expanding right now?
Sorry?
So the metal ball is expanding right now?
It's expanding. It's also sort of charged. Now here's the thing about the conduction. If I take this metal loop and I start to heat up the middle, what should happen to the loop?
It get bigger slowly.
It should get bigger slowly. Because like we said, we can take the heat from this side and it's bumping all the particles, and it'll keep bumping the particles until it bumps the particles in the hoop. That was not as good an example. Here's something else I would like to show you, if I don't set this on fire.
Set on fire.
I don't really know. What I have here is something that looks like a star. And attached to all of these are different types of metal. Okay? So I know you can't see it here, but this says S, so that's steel. This one says B, that's brass. This one says A, that's aluminum. This one on the side, that's galvanized steel, and this one is copper.
Hold on, which is which?
Copper, steel, brass, aluminum, galvanized steel.
Now,
No, it's not cool. No, we're not that. So here's the thing. The last thing about conduction is different things conduct differently. Because if I heat it, now what I have on top of here is I've got some beads and they've got wax holding them on. So if I start to heat this up, what do you expect to happen?
which one's going to fall first?
Sorry?
They'll fall separately.
They'll fall separately. Which one's going to fall first?
Pink.
The pink one.
No,
Okay.
the blue one.
The blue one?
The pink one, like.
So I've got some pink. Who's cheering for the pink one?
Oh,
wait,
it's not pink, it's not white.
Which
one's pink?
Pink one is, I can't see.
The
without
middle one,
setting
the
my
middle
face
one,
on fire.
like, middle one.
Pink one is
Brass?
steel.
Steel? I think the middle one. And the other one?
is lower part.
Copper? Oh, I was right, the middle one.
Middle one?
Which one was that?
The mid. That's the aluminum.
Aluminum.
Oh. Wow.
No, but aluminum dissipates heat. Oh, that's why.
Good. So it's So here's what I want you to consider. In that diagram over there, we've got like the particles that are moving fast, and then they'll bump into the particles moving slowly. Whoops.
Blue one down.
Why? Now the question is, why did these metals all melt the wax differently?
Because some metals conduct. Because their energy is slower.
Okay, so some metals can conduct energy faster, some metals can conduct energy slower. What does it mean for something to conduct energy faster or slower? In terms of what we know about the particles? Yes, that's what we're talking about, but that doesn't answer the question. I was getting tired, but that's okay. So what does it mean for something to conduct energy faster or slower? In terms of the particles? It would transfer heat faster. But what has to happen if you're going to conduct heat between particles? There's one key word. What happens to the particles? Yeah.
Move faster.
No. Are you raising your hand up or are you just stretching? Then, this is a really important question. If you get this, then you understand conduction. What is the key word that explains why some things can conduct heat faster and some will conduct slower? What has to happen to the particles? They have to transfer, but how do they transfer?
It moves.
No, it moves, and what happens when they move?
It moves the other way.
No,
They
not
need
expand.
space.
They need space, and what do they do when they need space?
Okay, so
They
they
push each other.
They push each other, so they collide. This is the key word. In conduction, you're talking about particles colliding. They have to hit something. So in these different metals, some of them are packed closer together, so they'll collide a lot more easily. Some of them don't collide as easily, so they transfer heat slower.
Galvanized steel should be the last one.
Yeah. Well, it also depends on the amount of wax.
You need to take that giant choke though.
Whoops. Wait, any questions about that? Yes.
If you push the hot metal rotor down the paper would set on fire with them?
No.
Oh, put cold water on it.
No, it won't.
Put cold water on it. Oh, there we go.
Folks, you can even do that at home.
Any questions about that?
Oh.
So that's conduction. Here's the important thing about
That was a great lesson on science.
there must always be contact.